Before we get started and hand over to Jürgen, I just wanted to mention that at some point we should talk about how any solution would be ratified by the VirtIO, I think, Oasis people, especially for automotive use cases. They seem to pay a lot of attention to formal acceptance of any, VirtIO solution. So, and then the other thing to mention is non-Linux guest VMs in OpenXT and Cubes. We use Windows, and FreeBSD is still a pretty popular workload for networking and storage. So that's all I had to say. Jürgen?
Okay, thank you. I think. Wait for a moment. Okay. I think I share one window. I hope I can find the right one. Just to. Okay. Oh. That's interesting. Yeah, get the right one. Okay. Just to show what I'm really setting here as device model arcs for the one device. So this is quite unhandy. I needed to do it that way because I need to force VirtIO block to be in non-legacy mode, which is possible only if I set some very special parameters here. I'd really like to discuss first how to configure VirtIO devices in Xen guest config files. Because, of course, there is the possibility to add it here in the disk line, basically, and adding a VirtIO specifier, like is done, for example, by the recent patch by Artem, I think. On the other hand, we need some generic way to do it for other device types. So, what do you think? Should we have both ways, or should we have only one way to do it? So, should the VirtIO disk be added under disk, or should it be a special VirtIO disk, or whatever?
If there is many devices, I know VirtIO supports more than network, frame buffer, etc. I'm not sure we want to have like one VIF, one frame buffer, one GPS, etc. So maybe what we want to do is like a generic device options, which would describe like saying this is a block and this is a GPS or something like that. So we do the a bit similar to what QEMU is doing. I think you have that on your command line, yes, manage device, VirtIO block, PCI, etc.
Yeah, so on this line here.
Yeah.
Yeah, I think so as well.
I think the other way could be better. I'm talking from the perspective of adding libvirt bindings, and if the configuration interface would be different for VirtIO, that would mean duplicating the whole disk handling in the libvirt binding for this. So it would be more convenient for API users to have unified way for disk, unified way for networks, etc.
So I think the disk is actually a bad example, I think, because the disk, we already have a line for the disk, and we already have a way to specify different types of disk. I think, and I'm misremembering now, but disk and network, even for the network, we have a way today to specify I want a VirtIO network backend that is already existing. I think the other method, the one you're describing, is a lot better for maybe other devices, such as VirtIO RNG is a random number generator, or a lot of the other devices. That is interesting, right? That is where Julian's question is really valid. I mean, do you want to add, a VirtIO RNG, a VirtIO here or there? You have many other little VirtIO devices. I think for those, the device model arc is probably the best way to go, at least until somebody wants to put in the effort to hook every option through.
Well, so something I was going to point out was...
One thing first, would someone please take notes? I think StackTrust, whoever you are with real name, could you take notes? Would it be possible?
For the VirtIO session?
Yeah.
I can try. I think Christopher might also be willing to help, being a VirtIO person.
Yeah, I'm sitting here scrolling stuff.
The risk is that, I mean, so since Christopher is going to be speaking, presumably at some point, having someone who's not going to be active, it's really difficult to take notes and be actively involved in the conversation. So I could try to take notes, but I hope to, at some point, at least parts of it be active as well. So, but I think it's better me than Christopher.
Okay, fine with me.
That's my son in the background.
Assistants, yeah, okay.
So one question I was going to ask, given that a lot of this is PCI based, even if we are going for a non-DMA transport, one of the specific features we have in Zen that is something we would wish not to lose is the fact that we've already got multi-IREX servers. So, for example, even at the moment for VMs in Zen Server in particular, we have QEMU running for most stuff and something separate handling the graphics card for the VM. I think it would be entirely feasible to be able to have a VirtIO backend that isn't QEMU under this model. So we probably don't want to tie the configuration to QEMU in particular, especially if there are going to be backend providers that aren't QEMU in this case.
Yeah, especially as for ARM, for example, I think MMIO-based configuration would absolutely
and based on KVM tools, right?
Yeah. Something like that. So we should be flexible in this regard, I think. Maybe MMIO-based would even be better for PD and PDH as well, for not having QEMU device model, basically.
Sorry, can someone summarize what we're talking about? Because I was trying to summarize the previous bits of conversation about the interface, and I can't figure out what we're talking about now.
Yeah, so the basic thing is, for one, how to configure VirtIO devices, and then whether it really makes sense to tie this to PCI specification or not, because in some cases PCI might not be the correct or the best way to configure a VirtIO device in a guest, especially if it doesn't have any PCI detection mechanism.
So what example there would you be going for there? Because the thing is, PCI is fairly standard, even if we're entirely emulating it.
The main trouble I can see with the MMIO is you can't easily unplug a device because for each VirtIO you will need a range, and therefore you will need to know in advance how many devices you want to give to your device, to your guest in advance. And as well, I think even on ARM, the PCI is going to be better because you can unplug easily a new device.
Right, but you need to know that ahead of time anyway, even for VIFs and VBDs. I know we give the illusion of being able to hot plug them later, but you're still limited at things like the grant limit on the domain and the event channel limit. So whilst we give the illusion of being able to hot plug with no upfront planning, it isn't actually something that exists in reality.
But I don't see why we want to. We want the same thing. Like, if we're not using ground but something different, then you may not need those limits, and therefore it seems to be an artificial limit to me.
Yeah, in any case, you would have the MMIO area you need to.
So the VirtIO transport is determined by there's the guest driver. This is the guest VirtIO transport driver, and it's either PCI or MMIO, or I think in Jürgen's case it's this grant based thing.
No, it's still so. PCI and MMIO are not mutually exclusive. So PCI is just a wrapper around MMIO, right? Via PCI, you just specify where the MMIO areas are.
Yeah, so I think actually, in fact, Jürgen is right, and so PCI and MMIO is only used for enumeration, right? Everything else is the same. In fact, it's probably one or the other is probably driven by the guest that you want to run, and because it's not really a big impact, I think it's probably not really the best topic to discuss, right? Because if somebody has a guest that only does MMIO, right, then it's gonna have to do MMIO. Somebody has the guests that only do PCI, they're going to have to do PCI. So it's going to depend on the deployment and the ecosystem of guests. And in any case, for us, I don't think it makes a huge difference. It's actually the smallest of differences. So, yeah.
Yeah, basically, yes.
I mean, for me, I think one of the more fundamental things I would thought would be with trying to hash out would be Argo versus grant table versus shared memory.
Exactly.
I don't think they're exclusive. I think they can be done on a per device basis. I think even MMIO and PCI can be done on a per device basis.
Correct.
Okay. Well, I guess how much of how much is duplicated effort to do that, or is it pretty easy to just kind of swap them out?
I think they're completely orthogonal. I think if you build the Argo driver, the Argo VirtIO driver, you can have VirtIO devices that use that as a transport. They'll be enumerable via the Argo channel to whatever on the back end, supporting your device discovery. And you can have mandatory access control over the data transport, which is, it's definitely going to be important for some VirtIO use cases.
Right, but I guess what I'm saying is, would it make sense for you to make a case to try to convince everyone else to standardize on Argo? Like, is there a reason to implement 3 different transports instead of just implementing one? Like, why duplicate the extra effort if they're actually
my concern on this is I actually don't have a preference from a technical point of view. As long as we have one, right, that works. And my concern is really what George just said, right? So all of them require a spec change, right? And to me, that's what I'm worried about.
Stefano, why do you think the grant approach requires a spec change? I don't see that as mandatory.
Because so that's actually a good question, right? And I might be wrong. I think it requires a spec change because the VirtIO spec today actually say that you need to pass guest physical addresses on the ring.
So you don't need a spec change, right? In the VirtIO Argo work, right? We did the analysis, and there is a translation step that is possible in the transport layer. So you have the VirtIO Argo driver that goes into the guest that works similarly to VirtIO MMIO or VirtIO PCI. VirtIO Argo is a transport, but once that's there, that can enable the translation function so that you don't need to change the spec.
Yeah.
The problem, though, is
don't you need a spec change for the configuration negotiation step, like to announce the feature?
No, it's part of the transport driver. The transport driver has the role of doing enumeration, so it's completely up to the implementation of that driver what you do there. So it can be entirely encoded inside that.
So, but that has two downsides, right? So the first one is actually VirtIO Argo will have to be added to. This is the thing about VirtIO. VirtIO means a number of different things, right? There is a spec, there is a transport, there is the drivers, and they're all a little bit separate. I thought that the transports themselves were part of the spec, like the VirtIO PCI and VirtIO MMIO. They are spec'd, right? So if we add one more, don't we need that in the spec?
No, Stefano, for one, you were wrong that the VirtIO spec is demanding to have physical addresses on the ring pages and so on. That is wrong. Those are DMA addresses. And if you have a special DMA mechanism, which happens to be grant, that's fine in my opinion. You have a special DMA engine.
Yeah, DMA addresses does not mean an identity map onto physical or guest physical addresses.
Right. DMA addresses are absolutely... So those are DMA addresses on the rings and wherever. So it's absolutely fine to have something different than PFNs.
That's excellent news. I think I was remembering an older version of the spec before they added the flag that you mentioned that I can't remember how it's called, the one that allows for DMA addresses. So yeah, that's good.
So I can have a look, but I think this was... Okay, so, and regarding feature bits, there are several feature bits, of course, available, and there's one feature bit I was especially looking at.
So real quick to Stefano's point, because I just pulled it up. So there is a specification for the transports, but if you are implementing a PCI transport or an MMIO transport, they have certain characteristics of how those should behave. So the way the driver, the transport interface is fixed. It doesn't fix the transport back, which is what the analysis is that Christopher and I were looking at.
So I think I didn't follow. Sorry. So you're saying they are spec'd, but they don't fix that there are only two. Is this what you're saying?
What I'm saying is they're fixed in the fact that if you think from the front end perspective, right, there's VirtIO drivers and then there's VirtIO transports. The interface between the driver and the transport, if the transport is being presenting itself as a PCI bus transport, there is an interface that the driver expects that transport to provide. It doesn't fix how it happens from the transport back. Okay,
so if you have a front-end transport, the front-end VirtIO driver expects to hand physical addresses to the front-end transport, but then that front-end transport can then convert it to grant tables or whatever it wants to do. Is that what you're saying?
Right. Yes, and it's a lot more complicated than that. There's a whole lot of behaviors that I'm skimming through it. There's a whole lot of, especially for PCI, of like certain structures that are expected to be there and all this other stuff, right? So that way the drivers can expect a common behavior for any PCI transport implementation. So your transport is your translation layer that you can handle dealing with what is the actual physical backend mechanism that you're actually going over.
So the plan would be to add a new transport. I guess that will need to be described in the spec proposed, and
no,
then
it doesn't have to be added to the spec.
Okay, so you will add a new transport, and then advertise it as different. But would the existing front end work with it? They wouldn't, right? I guess.
Well, the existing front end drivers would work with the new transport. But if you had an operating system, like if you took like a current VM image, it's going to have the current it's not going to have that transport implemented yet, right? So you would have to update to a new version of the kernel or a new version of your image to get that transport. Is that what I'm hearing?
No, well,
No.
that's one way. So for instance, like Argo, I can't remember, Christopher can answer whether we are looking at MMIO or versus PCI as what we're presenting ourselves as. But we would present ourselves as either a PCI transport or an MMIO transport. But that's what's presented to the driver. So the driver can have an understanding of how to interact with the transport. And the transport would then handle however you want to move back, right? So in Argo, we would basically move everything onto Argo rings. As far as what you would have to do to gain that, so if it's on the Linux kernel, that's why I was asking that question. On the Linux kernel, you could just do an out-of-tree kernel module and just load that up without having to really require any recompilation of the entire kernel unless they didn't have loadable module support.
Right. So you have to have the front-end transport in your guest one way or another.
Yes.
So yes. You can't just download an existing image unmodified off the internet. Expect it to work. You have to at least, as you say, compile a kernel driver that you can load in to make that transport available.
But the objective would be to get that into an upstream Linux kernel.
Exactly. Yes.
Right.
And then
frankly, between the people we've got here, we might even be able to get a front-end Windows driver somewhere useful.
Yeah. And
once
the transport's there. Go ahead.
The main issue is the amount of changes that are required to the ecosystem, right? And one of them is obviously the spec. How big is the change to the spec? In this case, it looks nothing. That's fantastic, right? Obviously, the less changes, the better, right? The second is the changes to the code, right? And in this case, the changes to the code seems to be only limited to the transport driver, which is a lot better, of course, than having to change on all the front-end drivers. I think that would basically be a no-go if we have to change all the front-end drivers.
Right. Yeah. Yeah. The point is you get to keep all of those. Yeah. And in fact, you should be able to plug them into back-end drivers, right, in the QEMU implementation.
So what about the back-end drivers exactly? So how many changes do you think they will need? Only again to the transport emulator and the actual backends will be the same?
Yeah, the actual backends will be unchanged and only the framework, basically, the lower levels, the transport layer, will need some modifications. This, of course, will hit all implementations of backend infrastructure, like QEMU, the kernel for the vhost backends, and if you have vhost user, all user daemons implementing the backend.
So that all sounds great overall. Something that was discussed very briefly during your presentation was the IOMMU infrastructure. Presumably,
Andy. So I think we've I'm not sure we've finished the question of are we going to use Argo or grant tables or something else? Is it okay if I be pedantic about that?
Well, I think the answer is we need both.
Yeah,
because there are people that need to not have shared memory, and Argo is an option there, and there are people who will want shared memory because it's faster. And nothing prevents. Yes.
Well, that was so. There is a performance is a good one to a good metric. The other one is also. It's not just Linux, right? So at least in automotive, there's going to be a number of OSs, and Linux is not going to be maybe not even the most deployed. So how, the question is, how good are our chances to convince third-party proprietary vendor to add a driver? Really, that's really the question. That's why I thought that some sort of shared memory was as a last resort, right? Obviously, if there is a faster mechanism, which could be grant table, just to name one, or even Argo, right? Maybe the shared memory mechanism as a fallback is still required. Because I'm thinking that if you've got to convince somebody to add something, the best chance you got is to say just add a memcopy and to copy to the shared memory, pre-shared memory region.
So I want you to toss in here to your assertion, Andy, that in a presentation maybe 3 years ago, Ian Pratt said that basically copying is faster than sharing memory, and he said that sharing memory is so difficult that no one is smart enough to do it. And we were all fools back in the 2000s to think we were smart enough to do it.
Yes, and I think I've made my feelings on his presentation quite clear. Not using shared memory can get around a lot of common bugs, but if you know how to do shared memory, it is still faster than data copying in enough cases for it to be relevant for us to care.
Particularly if you can avoid mapping and unmapping all the time, like if you can use some well-known regions.
Yeah. In particular, the way we get a lot of network performance in Zen Server is by not even mapping in the first place. We end up in a position where DOM0 constructs a scatter gather over the guest memory because it's an area that is granted, so the permissions work there, but is never actually touched. You can't do that with shared memory. With the copying mechanism. The copying mechanism would force a mem copy in a path where we currently have zero overhead transmit.
I would love. The thing is, I will hope and love to see the grant table is faster, but my empirical measurements so far always demonstrate that it's slower. So.
Slower than Argo, or slower than something else?
Slower than any memcopy mechanisms.
Is it related to the fact that we have to get around the problem of the atomic, as I mentioned in the previous talk?
It could be. All my latest measurements are all on ARM, so it could be.
Yeah, different architectures will make massive differences here on where the trade-offs intersect.
Just a question from me regarding ARM and shared pages. How does VirtIO on ARM in KVM work? Barely, or how do they do it on ARM?
They don't do any. The bad thing is that don't do atomics in shared page. They learned the lesson quite a while ago. On ARM, we can't do that because Xen is full of atomic in shared page, like event channel, etc. If we want to try to do something in VirtIO, then it would be nicer to avoid doing the same mistakes again.
Or we will have to require. Could we require like 8. Is it ARM 8.1 the one that introduces the new atomics, or 8.2?
Yes,
never remember.
But there's not many hardware with that. Today, even Xilinx, I think the latest may support it, but ThinQP will not support it. It looks like RISC-V also has the same issues.
Yeah, so I think what we're not necessarily saying that VirtIO grant is going to be perfect for all future use cases. And that's where other options do exist. But there are still enough cases where it would be a useful thing to have that it's worth considering.
So the question here is how people can use it in other hypervisor. Like, for instance, Argo, they've been looking at doing something that can be used in another hypervisor. I don't see that happening with ground table because of the problem I mentioned. The problem of security, etc., is not only Xen, it's KVM will have the same problem if they want to go in embedded, etc. So maybe we should look at something that we can use everywhere. People doesn't have to have specific driver for Xen because we're still tying VirtIO to Xen here at the end with ground table.
So there are two activities, speaking of which, just to make you aware, that are related and they're all based on shared memory. And one of them is driven by WindRiver, and they are doing a memcopy based approach, and that is not necessarily only for hypervisor, also between different heterogeneous processors like Cortex-A's and Cortex-R's. So that's one. The other, they are just doing, I think they're just pre-sharing the memory and then picking addresses off of the shared memory region. The second approach is from Linaro. That is meant for hypervisor like Zen or JLAUs, and they doing shared memory, but in a different way. I think the idea was to make it easier to upstream in Linux. Instead of pre-sharing an arbitrary memory region and picking address off of that, the idea was to increase, and this is where my VirtIO knowledge shows us lacking. So Jürgen, you might be able to correct my terminology, but they are increasing the ring size and picking addresses within the ring only. So the shared memory region is only the ring, and the buffer are within the ring, and the pointer points to things within the ring. It's still a shared memory region, but instead of being separate, it's basically the same as the ring.
So you mean it's basically all the I/O data is routed via the ring page or the ring?
Exactly. So they would increase the ring page to multiple pages and always put the data inside the ring.
Hey, Stefano, do you have any links to that?
I can look for one. So I can definitely introduce you to the people that will have the answer at least.
All right. Thank you.
Yeah. Also, they talked about it a few months ago, so by now they should have a demo, but I don't know if how much progress has made. But these were the discussions at least.
Okay, so it's not. I mean, I guess I think as long as it's kind of clear, like what the parameters are. So I mean, I think it sounds like from this discussion we could say, you know, at least on ARM, there's reason to believe that copying might be faster, and there are other advantages as well. On x86, I mean, other people might have made things differently, and so basically, if SUSE and Citrix want to work on the and maybe Vates or something, because of mostly x86 wants to work on the grant table one, and if the sort of EPAM and ARM and whatever work on the Argo one, then that sort of makes sense. But at least people understand why they're choosing which one. And
yeah,
to me, the thing that is worse is that all of these are like in a demo or pre-demo stage or less than a POC. If we had just one that is a bit farther ahead, would be a lot better than having 6 that are all not even a POC.
I just want to verify my understanding. So you can also do driver domain things with Argo, right?
Yes.
Okay.
Yes.
We'll check that. Yeah.
You were going to say something more, Christopher?
No, but I would say it would just be quite nice to have Argo as the transport and then able to use all of the VirtIO already existing guest drivers and guest device classes.
So do you imagine that with Argo there's going to be a memcopy and who or more than one memcopy, and who will do it?
So the hypervisor does the copy for the transport. The way that it works is the guest does a hypercall op to register a ring, and that basically allows the hypervisor to blit data in, and you can think of it as a DMA style operation for getting data into the guest. And
okay, so basically for each I/O data, there are 3 copies. First into the ring, then by the hypervisor to the other domain, and then out of the ring of the other domain to the target address, right?
No.
No, that's correct if both the source and destination are buffering the I/O in and out of their transport. Of course,
Right.
if they're happy to not buffer, the reason they're probably buffering in and out of that is because the backend is normally shared memory. But if you've got a guarantee that it's not shared memory, both sides. If you've got a guarantee that there is no shared memory between the front end and the back end, then neither the front or the back VirtIO driver need to buffer in and out of the transport.
Yeah, let's assume a disk I/O. I have user data in the guest. I want to write to disk. So I have some arbitrary data in memory. This needs to be written to the Argo ring buffer, right? That's copy one.
No,
Christopher, do you want to?
For Argo, it's only the destination side that has an Argo ring. The source side just passes arbitrary addresses. So from that point of view, it's a little bit like GABA DMA.
Okay, so it's like ground copy, basically.
Yeah.
So are we relaying, it's just more out of interest, are we relaying of Argo that the page is always mapped in then?
Yeah, for the rings, the way that Argo works at the moment is yes. If once you register a ring, that mapping is retained so that the hypervisor can do send to the ring when a hypercall is invoked.
Okay.
Question, I guess. Is it possible for Argo to copy memory from guest 1 user space to the ring in guest 2? And also, because that's definitely one thing. And another factor is, like, for instance, when it comes to disk I/O, I was looking at the ZFS issue tracker, and there are places where they have to take copies because generally it's not safe to operate on data that is shared with untrusted parties. So I guess from my perspective, whether or not in most cases you're going to have a copy, the only exception being if you have extremely carefully written data sources and destinations that are careful to only make loads exactly once. And unless you're using, and like from my perspective, unless I'm using something like Everparse or another tool that generates formally verified binary parsers that are by construction immune to double fetch bugs, I would prefer to just take the copy, because memcopy on modern processors is very, very fast.
Yeah, and
especially
I
if you can stay in
that's
cache.
why Andy was saying there's some people that are definitely going to want Argo because it's copying instead of shared memory, and the double fetch issues with the shared memory issue, I mean, is definitely an issue.
Yeah, I mean, there are a lot of good reasons. There are a lot of reasons why using shared memory is hard to do correctly. It's not impossible, but it's certainly hard.
So I want to just step back. I mean, we've got less than 10 minutes here. So is there more to constructively say about this topic, or do we want to try and touch on some other topic?
Yeah, so basically I'd like to come back to the configuration syntax, because this will be some major effort to get it right or just to implement it. And I think we should basically come to a conclusion whether it's better to have some generic VirtIO device configuration or whether it's better to have in the device-specific stuff or just a mixed variant.
I think it'd be good to have a generic saying I want a disk or I want a network, and allow specialization if you care to narrow it to the transport that you want. I think I'd have to dig into it. This is an off the cuff suggestion, but it would be nice to have flexibility for guests that don't really care. Let the platform select, and if for guest configs where you do care, have the ability to specify it. Seems useful.
Yeah, for example, for network devices, you might want to use a different copying mechanism. If you can avoid copies for network, that might be doable. Avoiding copies for disk may not be doable, so you might want to choose different mechanisms for disk and network devices. Yeah, of course. But the question was more, should the VirtIO disk be handled under the disk item of the config, of the guest config, or should it be a specific VirtIO disk item?
I think
or
we need to
VirtIO
keep
device
the old
type
option.
equals disk or whatever.
Yeah. I would like to keep the old disk and BoF options and expand them to support VirtIO, and then maybe you can add a generic VirtIO option that can be used to add the more esoteric devices that we don't support in any other way. So I think disk and BIFs and so on need to have some kind of type parameter. I think, BIFs already have one that allows you to select VirtIO as the backend.
And then having a transport layer specification as well, like none. So it's don't care what the backend is supporting, basically, or with grants or Argo or.
I mean, can we really limit
that? We have the same thing for like PCI, right? So it's like, do we want RDMR, RMR region strict or RMR region laxed or whatever? And you can set a global kind of default for XL, and then you can override it with a specific domain config, thing for specific. So you could say, in general, you want to be strict with RMR regions, but this particular domain, we trust it, so we'll and this particular domain with this particular device, we'll trust it, so we'll let it be relaxed or something like that. So you can have a system-wide thing that says, we'll default to, Argo, but for this one, then we want to have it be grants or something.
Or plain physical address or whatever.
Yeah.
Okay. Yeah. By the way, I just wanted to add regarding the specification, I found the bit which I'm using. It's a VirtIO F-Access platform feature bit. And this feature indicates that the device can be used on a platform where device access to data memory is limited and or translated. And this is exactly what we want. So, and using this bit, it's absolutely fine for grants or whatever.
And then you decide that you have this bit and you're running on Zen, so you have to use grants? Or is this bit allows you to select between grants or Argo or whatever else?
In the moment, so if you're using this bit, this would mean grants. Because this assumes that everything is done, the addresses are going into the ring page and so on and so on.
But I mean, you need to know that you're running on Zen.
Yeah, right.
Because that's a generic bit, that's not a Zen specific bit.
Yeah, right. This is currently used on 390 only, as far as I know. And there it has a special meaning. But basically, it's a special transport layer meaning.
So I want to make a comment, which is that if anyone remembers when libvirt was created, the people who come to a table and say, hi, I want to build a standard, typically are people who are trying to commoditize their competitors and advantage themselves, right? So the people who came first to build VirtIO had, their own priorities in mind. And it's worked, right? Because it kind of commoditizes the interface. And now every single hypervisor just blindly implements VirtIO because it's too expensive to do anything else. If you can use the Argo transport to put mandatory access control in, which by the way, many guests will need, suddenly you've turned this standard back into almost a Zen specific thing, because only with Zen will you get the strong guarantees from Argo, especially when you add hyperlaunch and all the other integrity pieces. So it's quite difficult for KVM, for example, to do a mandatory access control transport for VirtIO. So just keep that in mind. Argo is a differentiator for Zen from a marketing.
From that point of view, one could say that in theory it's a pre-shared memory region approaches, whether it's by, I found the name as they refer to the larger VirtIO, they call it fat VirtIO approach. And I was trying to find the architecture, but apparently the demo is to be coming soon. So that's going to be implemented anyway, right, outside of the Zen community. So those approaches should work on Zen anyway, right? Because they're like hypervisor agnostic. As long as you can increase the size of the VirtIO or pre-share a memory region, one way or another, they're going to work. So,
okay, we're over time, so we want to end